So my name is Brandon Lingo, and I will be going over my project, which I've been working on this summer, which is feature localization, and it's part of the aerial inspection project. So a little bit about myself. I was born and raised in Las Vegas, Nevada. I attended UNLV, where I'm getting my degree in computer science, and I am a rising junior. So a little quick overview of my project. So the way it works is that you fly a UAV over an aircraft, and there are two cameras attached to that. One is used for the navigation portion of it, and then the other one is just a normal camera, which its sole purpose is for looking for any defects. And so by defects, that can be scratches, dents, something you wouldn't want on the plane, and you would need to fix. And so you can plot the location of these blemishes in a 3D model version, or a 3D model aircraft that's the same as the aircraft in Afterburner. So Afterburner is the 3D engine that I use. And so basically this project cuts the need for any maintenance crew to go out and look for these defects by hand, which can imagine if you're on a C5 or a C17 or a C-130, that can be very time consuming on the size of the airplane you're inspecting. And so here's the pipeline for the way it works for the feature localization portion. So it starts off with an Alvium camera, and that's the camera that is attached to the drone. And then that sends its frames to a camera acquisition module, and then that module streams its frames to a yellow inference module. And so this is actually the part where it'll look for any blemishes. And so I trained a neural network to locate, or to find bullseyes in a frame. And so you will see that here in a second by bullseyes. And so that module will send its bounding box results to my module. And my module is also receiving some pose from the navigation module, which is the other part of the project. Okay, so the simulation pipeline. So since I can't actually be using a drone and a camera at all times, I have a virtual vision sensor loaded into a separate module. And so this module, which is this navigation module, basically represents basically the real life version. And so this pipeline pretty much works the same as the other pipeline. Of course, the camera acquisition module, you can imagine that it's just inside of our virtual vision sensor, because we can get the frames from that virtual vision sensor in that basically test navigation module. And so everything will work the same. And so here on the left is the actual scene I've been working on. This is basically from the navigation module. And so you can see here we have an F-16 loaded in the mocap room, and there are bullseyes scattered around on the airplane. And so on the right, this is the point of view of the virtual vision sensor. And so the virtual vision sensor is this right here. It's not, I loaded this 3D model. It's just a camera model that I loaded around it. And so just to represent it, so here's what our yellow inferencer will be inferencing on, and the images will be receiving. And so what that looks like is this. You can see our yellow inferencer has found all these blue bounding boxes. And so the yellow inferencer will package all those bounding box information and stream it over to my module. And you can actually produce a direction vector based on all this information you're getting from these bounding boxes. And of course, that direction vector is centered at the center of each of these bounding boxes. So it'd be going basically straight through the bullseyes. And so that's, of course, if the camera intrinsics are accurate. And so the reason why we actually need to intersect with a 3D model of the aircraft is because if we look here at this gray square, so this gray square basically represents the view this camera has attached to this drone. And so this pink dot is a blemish which the camera sees. And so we can get the pixel, or the vector of the ray that shoots through the pixels on this image. So here is the vector of the ray, and the problem is we don't know where the vector ends, because images coming from a camera is 2D information, and So we don't know where this vector ends, and the way you can solve this problem is by intersecting it with a 3D model of the aircraft. And so this gives you the exact location of the blemish on the aircraft. And so doing these intersections, it requires you to actually store the model, the 3D model, into a acceleration structure. That's because on the mesh there are so many triangles, is that when you actually look for the intersection point and you're going through all these triangles and running, whatever algorithm you are, so it's probably usually going to be the Moeller-Trumbauer algorithm for intersections with a triangle. You need to store these triangles somewhere and parse through it efficiently. And so Afterburner, it actually has a function that does all this, which is really nice. It uses an octree, which is just a tree that has, each node has 8 child nodes. And so what's nice about this, it has a time complexity of O log n. You can see here on the graph, it is the orange line, and it is one of the best time complexities you can get. And of course, since we're working with a lot of meshes here, or a lot of triangles in the mesh, it's good because the more things we have stored in our octree, the more efficient it becomes because it's O log n time complexity. And that's, of course, if the tree is balanced. If it's unbalanced, I think it degrades to an O of n time complexity. And so here you can see that the camera actually finds them, and these are just a couple images of it intersecting with it. So you can see in this top left, it finds all 4 of them that are on the plane, but it will completely ignore the one that's off the side of the body. That's because, well, for obvious reasons, that doesn't intersect with an F-16. And so you actually need to specify the 3D model that you want to intersect with. So here I've specified basically display all intersections with this 3D model, this F-16 model. So here's just another angle, and you can see I go around and I do it multiple times from different angles, and it finds each of them. And of course, this is perfect in the simulation pipeline because the pose we're receiving and everything is 100% accurate. So there is going to need to be a little offset added for the real life pipeline. So next steps working with this, I've already done this first one actually, but after that I need to start adding more documentation for the code before my time is up here. Refactor and clean up any code that so other people can understand, maybe change some variable names that I only understand. And there's a flight test coming up at the end of the month, so I need to start tidying up everything and making sure everything is ready to go before I leave. Anyways, thank you for everyone listed here. I've had an amazing summer at the Ant Center, and yeah, thank you.